Hello everyone. First of all, a very happy new year to all of you. Hope everyone is doing well. And thank you for joining the conference. So, my name is Sanchari Chatterjee, and I'm a PhD student from the Department of Computer Science from University of North Carolina at Charlotte, USA. So, today I'll be presenting my research work on cloud mining actionable pattern discovery in big data. So, moving forward, these are the outlines that I'll be covering today in the conference. First is problem definition. Second is introduction of the problem. Third is related work, which contains action rule mining, meta action, recommender system, emotion mining. Fourth is data set description. Fifth is method. And sixth is experiments and results, and followed by conclusion and future work. Moving forward, this is the problem definition. So we all know internet computer storage datas from users and sensors are piling up. This requires more time and space than a single computer can cope up with. Ecosystems like Hadoop helps to store and process and retrieve back the data efficiently in a distributed fashion. The regular data mining doesn't work. There is a need to adopt new big data technologies. Data mining finds substantial improvements over such distributed framework to process a large volume of data in a lesser time. Approaches proposed to do data mining and machine learning tasks, that is classification and clustering in a distributed setup by using Hadoop MapReduce, Spark, and other cloud platforms. Very little work has been done in adapting actionable pattern discovery algorithms to big data and action rules in a distributed environment. So the problem definition continues. As you all know, my paper related to emotion mining. So from where we get these emotions? Social network, blogs, public forums, electronic mail, surveys, etc. provide text that contains writer's feelings, opinion, or emotion. Now that text can even trigger reader's feeling, opinion, or emotions. For that reason, we used actionable pattern discovery that actually reduces the volume, appropriate interesting measures are adopted, and it suggests improvements. Here in this research work, we have proposed modified hybrid action rule algorithm with a threshold called rho. This is the introduction slide, actionable pattern mining. So knowledge discovery is basically the process of extracting patterns from massive data sets. Actionable knowledge extract helps to discover actionable patterns given from that data set. Action rule is the knowledge extraction technique for transition of one state to a desirable state. Rule-based learning is a simple data mining method that can be adopted by this technique. So rules take representation of antecedent, that is the if condition, tends to consequent, that is a result. In actionable patterns, the conditions are replaced by sequence of actions to achieve the result, that is the goal or the action or the desired state. So, opinion mining and human emotions. People are driven by emotion and performances are driven by people. Opinion mining is the process of extracting valuable data from different opinions of different kind of people to actually assess their feelings and thoughts. Now, mining this opinion of people has applications in several areas. Understanding what people may like or dislike is very critical for making informed business decisions, political decisions, improved techniques for teaching and learning. Now, these are wide variety of sources for emotions expressed by humans. How we can express? We can express through body language, music, speech, facial expression, text. The focus is mainly on text data because of the growth of textual data from sources like email, customer reviews, social networking sites. Now, here we have an example text that is, oh wow, would love to one day have a tour. Best team. This is a joyful statement or a happy state. What is emotion? So the origin of word emotion dates back to 1579 from a French word called émouvoir. Ellen Fox gives a formal definition of emotion. Emotion is a discrete and consistent response to internal or external events that have a particular significance for the organism. Now, this is the research focus, emotions in student survey data. So we work on a novel approach of using student feedback for courses labeled with emotion and provide suggestions on how to enhance emotion. This in turn lead to better teaching style, learning outcomes, and a comprehensive environment. For this purpose, we use actionable pattern discovery method as mentioned earlier. And actionable patterns discovery method are basically showing off the patterns that help benefit the user to achieve better outcomes. Now, we have also worked with the Net Promoter Score, that is the NPS data, worked with the emotion of that data. So we have used the NPS feedback, that is Net Promoter Score feedback from customers labeled with emotion and provide suggestions on how to enhance their customer emotion. This in turn leads to gain better insightful knowledge on customers' attitude towards the service. For this purpose, we again use actionable pattern discovery method, and we know this helps to benefit the user to achieve better outcomes. So action rules are very important in modeling expert and domain knowledge. Action rule mining is one of the actionable pattern mining approach that helps extract action rules and are extracted from a decision system that suggests possible transition of one state, quite undesirable state, from one state that is a better state or a desirable state. Now, in data mining literature, we see two predominant frameworks for action rule generation. One is the rule-based, that is loosely coupled, and object-based, that is tightly coupled. Rule-based action rule mining is the extraction of action rules or actionable knowledge is dependent on the pre-processing depths of classification rule discovery. This method actually uses the pre-existing classification rules or generate rules using algorithms like learning based on rough set, that is LARS, and extracting rules from incomplete decision, that is a read system. Rule-based methods are further divided into method generating action rules from certain pairs of classification rules, like discovering extended action rules, DEAR, and methods that generate action rules from single classification rule and action rules based on agglomerative strategies. Now, object-based action rule mining are the extraction from table, that is arrayed association action rule methods extract action rule directly from the database without the use of any classification rule. Now, this is classification rule and this is action rule. So classification rule contains learning from example based on rough set, that is LARS or decision tree, and action rule contains DEAR, that is discovering extended action rules, or ARAS, as mentioned in the previous slide. Now, this is meta action. So meta action tells the action that they can undertake within their organization to make that happen. Basically, action rules suggest that the user should do whatever in order to improve their customer ratings or to improve their emotion. Now, the actions which trigger changes of flexible attributes either directly or indirectly because of some correlation among certain attributes in the system are basically called meta actions. So here is an example of an action rule where the state changes from detractor to promoter. So I'll explain the action rule. So here it's benchmark parts availability when it changes from 4 to 9, and when the division, that is Wagner heavy equipment parts, remains same, the promoter status changes from detractor to promoter with a support of 2 and confidence of 79.48%. Here, basically the customer looked for parts availability. The company needs to figure it out why it is getting late, if it is getting late after being ordered. Do they have the parts already in the warehouse? If not, then what they can do to make the customers happy. So these are the meta actions that are basically given by experts. So we did not obtain them from the data, but they were given by experts. Like if this is a student data, then the expert will be the professor or the director of the university. If this is for medical data, then the expert is going to be the medical doctor. And if this is for a business data, then it's going to be the chief executive officer or the stakeholders of the business. Now, what are the example meta actions that we found from the expert on the basis of this action rule? So we can improve the supply chain. We can improve the record keeping of parts storage process. We can obtain parts from different suppliers so that they can come quicker if it's not available in the warehouse. So this is the recommender system. So basically, recommender system aims to increase the reachability of products, and it provides alternatives for potential customers. For example, hierarchically structured recommender system is to improve the efficiency of a company's growth engine. That is, giving hint to company how to improve their net promoter score ratings. So basically, net promoter score is a measure used to gauge customer loyalty satisfaction. It can be calculated by asking customer one question or two questions. So recommender system can actually provide actionable recommendations to improve the customer churn rate. For example, actively engaging the customers with the product, often refers to as relationship marketing, give you the customers reasons to keep coming back by showing them the day-to-day value of using the product, by making the products, services, offers a part of their daily workflow. So emotion mining. Emotion mining gained attraction in the field of computer science due to the vast variety of systems that can be developed and promising. Applications like healthcare system, customer care services, smartphones that react based on users' emotions, vehicles that sense the emotions of the driver system. Scientific studies on human emotion has given two prevalent theories. One is discrete emotion theory and the other is the dimensional model. Discrete emotion theory states that four basic emotions are served by independent neural systems. On the other hand, dimensional model states that all emotions are combination of four neural sensations. Now this picture shows the circumplex model. According to the author Posner, in this model, joy is the product of strong activation in the neural system associated with the positive valence together with moderate activation in the neural system associated with arousal. Now, these are the applications of human emotion in some of the fields. So, opinion mining can be accomplished through emotion detection. Emotion detection has its root in many disciplines apart from computer science as follows: human science, psychiatry, nursing, psychology, neuroscience, etc. Emotion mining and actionable pattern discovery can be applied in social media data mining, educational data mining, business data mining. So these are the student emotion about active learning approach. So this measures the student satisfaction, opinion, and emotion about active learning teaching approach used in the class. So when we think of an innovation, it can be in terms of education. It can be applied as a teaching technique, pedagogical approach, learning style, or process and institutional structure. Active learning approaches are gaining attention and popularity in higher education. So lightweight teams are introduced. Lightweight teams are an active learning approach where the students work together in a group, but they have a very little or no direct impact on their final grades. So now let's talk about the data description. So this is the student survey data description that has attributes, 59 attributes, including team sense of belonging, team member responsibility, teamwork, help diversity, group assignment benefits, active learning methods, video case assignment, peer teaching helped better learning, flipped class helped better learning, of course, student emotion. So these are how we have collected the data. These are the attributes: teamwork, active learning and teaching methods, student emotions, campus facilities, background, experience with faculties, help to develop and design the survey questionnaires. For example, did you gain any benefit from group assignments or not? Kind of this. And then we pre-validate the questionnaire. Then we administer the questionnaires using Google Form. And then the survey was distributed to students in courses with active learning pedagogy, implemented as teaching and learning style. So for a net promoter score, we have collected customer feedback data related to heavy equipment repair. The entire data set consists of 38 companies located in multiple sites across the whole United States, as well as several parts of Canada. Overall, there are about more than 3 million customers surveyed in the database over time span of 2011 to 2015. Customers were randomly selected to answer a questionnaire which was significantly designed to collect information relevant to the Net Promoter Score. All the responses from customers were saved into the database with each questions that is benchmarked as one feature in the dataset. So benchmarks include numerical scores from 0 to 10 on certain aspect of services. For example, if the job is done correctly, are you satisfied with the job, likelihood to refer, etc. The data set also contains customer details, for example, name, contact, etc., and service details, for example, company invoice, type of equipment repaired, etc. The decision attribute in the data set is promoter status, which labels each customers as either promoter, passive, or detractor. The decision problem here is to improve the customer satisfaction loyalty as measured by the net promoter score. So the goal of applying action rules to solve the problem is to minimal sets of actions so that to reclassify customers from detractor state to promoter state and thus helping the NPS. So for our experiments, we use survey given by customers for two companies over the year of 2015. We have used 17 California and 30 to 35 data sets for our method. Each of NPS data consists of around 1500 unique surveys from multiple customers with around 25 unique questions. The original data for 17 California contains 547 instances and 23 attributes. And the datasets for company 30 to 35 contains 3335 instances and 23 attributes. Now, these are the action rules. So, as we can see the table, so this is the decision system S. AST is the stable attribute, AFL is the flexible attribute, and D is the decision attribute. So here X to X1 to X10 is the row, and A, B, C, D are the attributes or the variables, you can say it as. So these are the atomic action terms. So the blue one is, of course, the stable attributes, and the red ones are the flexible attributes. So the atomic action terms means an expression that is for variable or attribute A. It changes from A1 to A2, where A is an attribute and A1 and A2 belongs to that attribute A. If A1 is equals to A2, then A is called stable on A1. In this case, for simplicity reason, we use notation A1 instead of A1 tends to A2. So let's take a look of this sample action rules. So I will explain the first action rule, that is R1. So here we can see that is for A2, the B's are changing. So A is a stable attribute and B is a flexible attribute. So B is changing from B2 to B1 and H is changing to A. That is, the decision is changing from state H to state A. Now, if we look into the row X2 and X3 over here, we can see this action rule. That is, the A2 remains similar, but B2 is changing to B1, and of course, the H is changing to A. Now, if we look to action rule number 2, it talks about the stable attribute C, that is where we can see that C2 remains same and B2 is becoming B1. For example, if we see row number 6 and row number 7, we can see that H is changing to state A. Now, this is the decision system S. So there are 4 sets involved. So Y1, Z1, Y2, and Z2. So these are the atomic action terms. And of course, we know which one is the flexible attribute and which one is the decision attribute. So Y1 consists of X2, X4. Z1 consists of X1, X2, X3, X4, X5, X7. Y2 consists of X1, X6. Z2 consists of X6. So how we can measure the support and confidence from here? So the support is measured by the cardinality of Y1 intersection of Z1. So for example, if we take these two sets, so X2 and X4 is in common. So the support becomes 2. And for confidence, how we can measure that? We can measure by using cardinality of Y1 intersection Z1 by cardinality Y1 multiplied by cardinality of Y2 intersection Z2 by cardinality of Y2. So this one resembles the confidence as half. So this is pretty similar with the previous slide. Just the thing is the action rule has changed and the set has changed. So there is nothing much to explain this slide. So this is also a technique. This slide also explains about the different technique of measuring support and confidence. So here you can see the set has got changed and so the support and confidence has also got changed. So depending on the set, the support and confidence changes, of course. So here we can find a new variable that is called utility apart from support and confidence. So how we can measure the utility? So the utility can be measured by the same process, like cardinality of one set intersection with the other set. So basically, the utility gives us the objects which have the potential to be acted upon and a change into the desired class or the desired state of the decision attribute. The higher the utility, the more useful or usable the action rule will be. So these are some of the action rule applications. So action rule suggests actionable patterns to achieve a specific task on social network by improving a user's way of writing, which in turn help them increase their friends and followers. We can use it in smart home, we can use in medical domain, and of course we can use in education domain. It will help to improve teaching method, class environment, student learning, etc. Now this is the association rule mining. So to find the association relationship, that is the association rule among set of objects in large database, we use association rule mining. For example, 70% of transaction that contains X and Y also contains Z. So here 70% of transaction is the confident factor, that is the consequent, and X, Y and Z is the antecedent. So this is the algorithm of our previous method, and this is the flowchart of the previous method, that is without the threshold. So this is hybrid action rule mining algorithm and flowchart. So this is our method. The method name is modified hybrid action rule mining with partition threshold row algorithm. So we have added a row partition threshold in to the previous method, and we have proposed this method. So this is the action rule mining algorithm. So which says about certain rules, decision from to decision stay to, then it talks about support confidence. So where the certain rules are provided by algorithm layers. So for example, for each rule R in certain rules, if the consequent R equals to decision to form action rule schema R, that is action rule schema tends to AR, then the loop ends and the for loop also ends. So for each schema in ARS, we have to identify object satisfying schema, form the partition while the partition size is greater than row, form the subtable, and while the subtable size is greater than theta, divide the subtable until the subtable is less than theta. So we have generated frequent action rule sets using a theory. And of course, we have got the action rules. That is, we have changed the decision state, that is decision from, to a desirable state, that is decision to. Now, this is the flowchart where you can see that we have added a threshold. Each case over here, if it's less than a row, then it will again go on the loop, and if it is greater than low, then it will move forward to followed by another threshold, that is threshold theta. So for experiments and results, this talks about experiment one, that is student survey data. The original data contains 549 instances and 59 attributes. So the data is collected in classes employing active learning methods as discussed in the previous slides. The data size on disk is 59 kilobytes. For scalability purpose, to test the performance of our proposed method with big data set, we have replicated the original student survey data 1024 times. Now this replicated data has a total of 562,176 instances. Size on disk is 58.2 megabytes. Now, for this is the previous data, like vertical data split method that divides the uh, data sets vertically. So we also perform these experiments on the student survey data using Amazon Web Services, that is AWS cluster with two nodes, 4v4 and 16 GB memory with EVS storage of 64 gigabyte. So for very large data, these methods required additional resources. So we find we must provide an extra 32 gigabytes of memory to compute the computation on replicated data in 2400 seconds. Otherwise, the method receives an out-of-memory exception with our replicated student survey data. This occurs because of iterative nature of the algorithm with large data that causes computational overhead and requires extra hardware memory resources to work successfully. This method only works for association action rules because it considers only subsets of the attributes. Now, this is the modified action rule mining with partition threshold row flowchart. I mean, this is our method. So we have implemented our method with threshold row by using AWS clusters with 2 nodes, 4 vCore and 16 GB memory and EBS storage process. So we have also implemented our proposed method using the Spark machine learning library in Scala programming language. And our proposed method took 39 seconds, 3900 seconds to complete computation on the replicated student data. So here we can see these are the runtime comparison for student survey data that works with threshold row and threshold theta. So I have experimented with 3 different thresholds, that is 5, 10, and 15 for each threshold, for threshold row and for threshold theta. So the optimum performances is shown for this one, where the row value is equals to 5 and the theta value is equals to 15. So the runtime is 352 seconds. So these are the implementation in Spark. So we extracted the action rules as described in the previous slide using Lars and on AWS cluster using Spark machine learning library. And we have extracted the action rule in order to reclassify the decision attribute emotion from sadness to joy and from anticipation to trust. So these are the sample action rules. So I'm going to explain the first one. So it talks about sadness to joy, change of state, where team formation changes from 2 below average to 4 perfect, and number of team members changes from 5 to 7 to 8 to 10. Then the emotion changes from sadness to joy with a support of 21 and confidence of 62%. This shows that when the student's sense of belonging to the team is average and the team contains 8 or more members, then it upgrades the student emotion from sadness to joy. Now, for student survey data, we can see we have the runtime comparison of previous 2 methods with our method. And as discussed in the previous slides, that with standard memory, the vertical data split is out of memory exception, but with extra 32 gigabytes, it is showing on, I mean, it is giving the output on 2400 seconds. But on the same thing, if we are implementing on hybrid method implementation, the runtime is 5088 seconds and I mean 588 seconds and modified hybrid action rule mining with the partition threshold row is 3900 seconds. So these are the same process we used for our business data. That is, we have used the Net Promoter Score data. And I think I have explained in the previous, one of the previous slides about the action rules. And we have used the same uh, platform for finding the computational time for NPS data. But here the state changes from detractor to promoter. Hence, the emotion also changes from sadness to joy. So I think in the meta action slide, I have already explained about this uh, action rules. So these are the other 2 action rules for NPS data. So this is the runtime comparison for NPS data. Again, the same comparison we have got because the data size is same, similar. And the hybrid method implementation in Spark AWS clusters give the runtime of 5088 seconds and The proposed method that we have proposed with a threshold pro gives the 3900 second runtime. So, in conclusion, we perform the opinion mining in text by detecting emotion automatically. Recognizing emotions from text data through mining can benefit a lot of industries, including political, business, social media, and education. In this work, we mine student data service data sets and net promoter score, that is the business data. We experiment with student survey data sets and net promoter score data to test our proposed modified hybrid action rule mining with partition threshold row to suggest ways for improving human emotion. Our method can be applied to the following domains. It can be applied to a technology of futures like smart applications, smartphones, social network, education, customer care servicing, improve business revenue, and this mining actionable knowledge can actually help benefit emotion recognition system. So in future, we plan to experiment with larger student survey data and NPS data to study the scalability of our proposed modified hybrid action rule method with threshold row. And we also plan to experiment with values of threshold row as a percentage of the original data size. So we also expect improved performance with big data sets like medical data or Amazon data sets. So we expect the discovered action rule to provide suggestions on enhancing student emotion and overall teaching and learning experience with more active learning methods. Thank you. Any questions?